Your teacher today is Dr. Bosa, Science. Dr. Bosa is a teacher at the Science Foundation College, the best school that teaches sciences. Today, 16th June 2021, we are going to study lenses at O level. Our website is digitalteachers.co.ug. Please subscribe to promote this video. Subscription is free. Lenses are spherical, transparent materials that may be made of glass, plastic, water, and so on. Types of lenses: 1. Converging or convex lens. 2. Diverging or concave lenses. This is a convex lens. This is a concave lens. 1. Converging lenses bend parallel rays of light towards a common point. 2. Diverging lenses bend away parallel rays as if coming from a common point. Definition is: 1. Centers of curvature of a lens. These are centers of the sphere of which a lens forms part. For instance, here C1 is the center of curvature of surface 1, and C2 is the center of curvature of surface 2. 2. Radii of curvature of a lens. A radii of spheres of which lenses form part. All distances from the centers of the surfaces to the center of the spheres of which the lens forms part. For instance, radius for surface 1 is from C1 to the center of the surface 1. R2 is the distance from the center of surface 2 to the center of sphere C2. 3. Principal axis of a lens. This is a line joining the centers of curvature of the two surfaces of a lens. If C1 is the center of curvature of surface 1 and C2 is the center of curvature of surface 2, then the line joining the two centers of curvature is the principal focus. Then 4. Optical center of a lens. This is the midpoint of the surfaces through which rays incident on the lens pass undeviated. The center of the two surfaces of a lens is the optical center. Number 5. Paraxial rays are rays that are close and parallel to principal axis. So if this is a ray close and parallel to principal axis, then it becomes paraxial ray. 6. Principal focus, capital F. A. Principal focus F of a convex lens is a point on the principal axis where paraxial rays incident on a lens converge after refraction through the lens. So paraxial rays, we said, are rays that are parallel and close to the principal axis. The point where they converge after refraction through the lens is called principal focus. B. Principal focus F of a concave lens is a point on the principal axis where paraxial rays incident on the lens appear to diverge from after refraction through the lens. So the principal focus F of a concave lens is a point on the principal axis where paraxial rays or rays parallel and close to the principal axis appear to diverge from after refraction through the concave lens. 7. Focal length F of a lens is the distance between the optical center of a lens and the principal focus. Geometrical rules for construction of ray diagrams. 1. A ray parallel to principal axis after refraction passes through the principal focus. 2. A ray through the principal focus is refracted parallel to the principal axis. 3. A ray through the optical center passes undeviated. Note that all normals to the lens pass through the centers of curvature. Types of images formed by lenses. 1. Real images are images formed by intersection of light rays and can be formed on a screen. 2. Virtual images are images formed by apparent intersection of rays and cannot be formed on a screen. Ray diagrams for objects at various positions from a convex lens. A. Object between the optical center C and the principal focus F. A ray parallel to the principal axis is refracted through the principal focus F. A ray through the optical center passes undiverted. When we extrapolate the rays, then we form an image. The image is magnified or bigger than the object is upright or erect, then it is virtual. B. Object at the principal focus, capital F. The ray parallel to the principal axis is refracted through the principal focus. The ray through the optical center C passes undiverted. The image is inverted, real at infinity. So the image formed is inverted, real, and is at infinity. C. Object between F and center of curvature 2F. A ray parallel to the principal axis is refracted through the principal focus. Then a ray through the optical center passes undiverted. Then the image is real, inverted, magnified, and formed beyond the center of curvature to F. So image is real, magnified, inverted, formed beyond to F. Object at the center of curvature to F. Array parallel to the principal axis is refracted through the principal focus F. The ray through the optical center of the lens passes undiverted. The intersection is the image. So the image is real, inverted, same size as the object, same size as the object, formed at 2F. E, object beyond the center of curvature to F. Array parallel to the principal axis is refracted through the principal focus F. The ray through the optical center of the lens passes undiverted. The intersection of the two rays forms the image I. The image is real, inverted, diminished, between F and 2F. So it is formed between the principal focus F and then the center of curvature to F. F, object at infinity. The image forms at the principal focus F. So the image is diminished, inverted, formed at F. Red diagram for a concave lens. A concave lens is represented like this. A convex lens is represented like this. So a ray parallel to the principal axis is refracted away from the principal axis. A ray through the optical center of the lens passes undiverted. The intersection of the two rays forms an image which is virtual, diminished, and upright. Magnification M. Magnification is equal to image height over object height, or magnification is equal to image distance over object distance. Lens formula is given as 1 over F is equal to 1 over U plus 1 over V, where F is the focal length of a lens, U is object distance, V is image distance. Then sign conversion is distances to real objects and images are positive. Distances to virtual objects and images are negative. Example 1. An object of height 10 centimeters is placed at a distance of 50 centimeters from a converging lens of focal length 20. Calculate image distance. So from the question, we can see that U is equal to 50 centimeters, F is equal to 20 centimeters, but V is what we are looking for. So substituting in our mirror formula, we have 1 over 20 is equal to 1 over 50 plus 1 over V. Moving this one this way, you can have 1 over V is equal to 1 over 20. When you take this one this way, minus 1 over 50. The LCM is 100. 100 goes in 20 5 times. 100 goes in 52 times. Minus 2, which is equal to 3 over 100. Therefore, V is equal to 100 over 3, which is the reciprocal, which is 33.3 centimeters. Then 2 magnification. 2 magnification. Magnification M we said is equal to image distance over object distance, which is equal to 33.3 over 10, which is equal to 3.33. Example 2. An object height 10 centimeters is placed at a distance of 60 centimeters from a concave lens of focal length 20 centimeters. Find 1 image position. So what we do, we will use our lens formula. F is equal to negative 20 because the principal focus of a concave lens is virtual. Then U is equal to 60 centimeters. So 1 over negative 20 is equal to 1 over 60 plus 1 over V. 1 over V is equal to 1 over 20 minus 1 over negative 1 over 20 minus 1 over 60. When we take the LCM is 60. 60 goes into 20 3 times. 60 goes into 60 1 time, which is equal to negative 4 over 60 over 60. V is equal to negative 60 over 4, which is equal to negative 15. Negative because image is virtual. Then 2 image height from magnification is equal to V over U is equal to H over H, where H is the image distance. We can say it implies that 15/60 is equal to h dash over 10. Therefore, h dash is equal to 15 times 10 over 60. When we cross, we get to 2.5 centimeter. Usually, the image in a concave mirror is diminished. So, the object is 10 centimeters, the image is 2.5 centimeters, indicating that the image is diminished. Power of a lens. The power of a lens is given as 1 over focal length in meters. The units are diopters or capital D. Example fitting. A converging lens has a focal length 10 centimeters. Determine its power. So first we change the 10 centimeters to meters. So 10 centimeters is equal to 10 over 100, which is equal to 0.1 meters. The power is equal to 1 over F is equal to 1 over 0.1, which is equal to 10 diopters. Experiment to determine focal length of a convex lens. 1. Focusing the image of a distant object on a screen. The distance between the lens and the screen will give us the focal length of the lens. Uses of a lens. 1. In lens camera. Parts of lens camera. We have a lens, diaphragm, shutter, film. The lens focuses image on the film. The diaphragm regulates light entry into the camera. The shutter regulates exposure. The film is where the image is formed. In the eye, the lens focuses light on the retina. Differences between the lenses of a camera and the eye. In the camera, the lens is artificial. In the eye, the lens is biological. The lens of a camera has got fixed focal length. The eye has got variable focal length. Next, we are going to look at revision questions on lenses in physics at O level. Our website is digitalteachers.co.ug. Our sponsors are the Science Foundation College, the best secondary school in Uganda. On Digital Teachers, you can find free notes, free exams, free marking guides in physics, chemistry, biology, math, and primary subjects. The best primary school in Uganda is Rock of Ages Primary School at Chiwanga, Mukono District, Uganda, East Africa.